Good, so we are looking to review some vertex form and some step pattern. This video is suitable if you are in a 3C or a 2D class, but note this is a review video. This is not an exploration. We're not exploring to see what the vertex form looks like and how a stepping pattern works. We're looking to review them, what they mean. So now you'll need to make sure if you're in this video, you're really comfortable with a Cartesian coordinate system. That is, you're really comfortable putting something onto a graph from a table of values. And our video was called Graphing Quadratics by Equations. Really, you need to make sure that you are comfortable at this point, again, turning a table of values onto a Cartesian plane and recognizing a quadratic pattern as it goes. Now, a quadratic in vertex form, it's written like this. You may have been taught with some separate variables right here. You may have been taught this using a Q and a P or something like that. The variable letters don't really matter, but what matters is that you're able to recognize something's being subtracted, and that's important, subtracted from x, and something is being added after the squaring. Something is being added before we find our y value. Now, this k value is the y coordinate of our vertex. This is also the maximum or the minimum value. That is the optimum value that our y values can reach. That's given by the y coordinate of the vertex. Our h, and we'll be really picky here, h is whatever is subtracted from x. This is the x coordinate of our vertex, which is the same as what our x is equal to when we're working with our axis of symmetry. It is also the location of our minimum or maximum value that we saw from our k value. Alrighty, so the vertex of our quadratic is located, we could say, at hk, where h and k are written in as an ordered pair. That is, they are describing one location on a Cartesian plane. If that's the case, then I want you to state the coordinates of the vertex for these quadratics right here. I can go through A with you if you're not sure how to handle it, but if you are sure, just pause the video and then unpause to see how you did. Our vertex here for part A comes directly from whatever is being subtracted from x inside of our brackets, that is before any squaring is going on, and it comes from whatever is being added after the squaring is going on the outside of the brackets. So in this case, we're working with a vertex at 3, 5. Fantastic. If that's the case, part B, our vertex, is going to be at whatever is being subtracted from x and whatever is being added. We'll have to be careful there. Whatever is being added. Well, hang on, nothing's being added. I just see a -8. Okay, that means -8 is being added. So we're working here with a vertex of +1, -8. All right, I'll change up my color here just so it's really clear which question I'm answering. Okay, part C, here's where it starts to get tricky. Our h value is whatever is being subtracted from x. You might say, hang on, I don't see anything subtracted from x, and you're absolutely right. And then we get into the question, okay, how can subtracting something change to addition? Well, I'm not really sure, so let's go off on a little bit of a tangent here, and let's explore. If I have 5 minus 7, what do I end up with? 5 minus 7, okay, that's -2. Fantastic, good job us. What about 5 minus -7? Oh, well then I'm subtracting a negative. Okay, if I'm subtracting a negative, hey, that's like I'm adding. Okay, so that's like 12. So that's kind of like 5 plus 7. So really what's happening, if ever you see a plus, you could, if you want to, and often it's confusing, so it doesn't actually serve you, but sometimes it does, and this is one of the cases it does. If you ever see something being added that's like subtracting a negative, okay, let's jump right back and let's say, hey, we know our k value is whatever's being subtracted from x. What's being subtracted from x? It's going to be a -5. This is like x minus -5 here within our brackets. Okay, well, if that's the case, then our vertex is going to be at -5 and +9. Do I need that plus sign in there? Absolutely not. We don't want it. All right. And lastly, part D, our vertex, we're working with a -2, -3, where again we see that negative h value comes in because something is being added to x. All right, that is the first step. If you're working in vertex form, the first step is to find your vertex. All right, we found our vertex, good job us. Our second step, we've already seen there are two types of parabolas that we can work with. One of the parabolas opens up, the other parabola opens down. All right, now the way this will show up in your equation when you're working in vertex form is going to be in front of the brackets. You might say, hey, Mr. Pasatka, there's nothing in front of these brackets. You're right, there's nothing in front of those brackets. That's what tells us it opens up. All right, however, if we have something in front of the brackets, specifically, if we have a negative sign in front of the brackets, that tells us that our parabola will open down. Okay, so let's review for a moment. Now we've observed two different steps from our vertex form. We've observed the location of the vertex and whether the and whether the parabola opens up or down. Okay, well that's nice and great. Now, in order to get this nice smooth curve, it's not a straight line like you worked with in grade 9. This is a nice smooth curve. In order to get a nice smooth curve, we follow a step pattern. All right, our basic step pattern, which we will upgrade later, but right now our basic step pattern is simply we start at the origin, or really we start at a vertex, and then from there we go over 1, and we'll go to the right here, and then up 1. Fantastic, there's our second point. And then we go, that was our first step, and then we go over 1, this case up 3. 1, 2, 3. Hey, there's our third point. And lastly, we go over 1 up 5. We can see the pattern here. Over 1 up 1, 2, 3, 4, 5. There is our fourth point. Then we would go up 7, up 9, up 11, up 13, where every time this up value is changing, it's increasing by 2. Wow, we've seen that before when we worked with our second differences. Now, that's all well and great, but you might say, wow, this only looks like half a parabola. You're right, so we're going to perform that exact same strategy. Last time we went over to the right. This time we're doing the same thing. We're just going over to the left. Over 1, up 1. Good job. Over 1. From here, we're going over 1, up 3. Okay, from here, we're going over 1, up 5, and we can see this similar shape that's happening on the left-hand side. We're working with a nice parabola right here. We can get rid of these lines that I was using to just count my squares. That's a parabola. That's what we're looking for. Now, we'll need to be careful because this step pattern says we go up 1, up 3, up 5, up 7, and that's what we did over here. We went up 1, up 3, up 5. Then we would have gone up 7 if we had the space. Now, this step pattern is actually only true half the time. This is true if we have a parabola that opens up. But if it opens down, instead of everywhere here where it says going up, you just go down. It's nice and easy. It's that straightforward. So let's put that all together then. There are 3 steps that you can take if you are trying to sketch a parabola from vertex form. Your very first step is going to be to find the vertex. That is, you'll find the coordinates, and if you're sketching it, you'll put it right onto your Cartesian plane. Your second step is just check to see whether it opens up or down. And your third step, we're just looking to follow our step pattern, which again will be upgraded in a future video, but right now we're just using our basic step pattern. Now this basic step pattern we use up or down depending on whatever we found in step 2. Okay, if that's the case, I want you to try on your own. Pause the video right here. Question A, I want you to find the vertex, plot your vertex, check to see whether it opens up or down, and then use your step pattern, and then unpause the video, see how you did. Good, where we have our vertex here at 10, 2, we know it opens up, so we're going over 1, up 1. We'll do that in both directions. Then we're going over 1, up 3, and we'll do that in both directions. And then we're going over 1, up 5, and we'll do that in both directions. Could we go up 7? No, it will not fit. So our parabola, don't forget to sketch in your parabola right here. Remember, your arrows mean I ran out of space. There's no more graph left, but my parabola continues. So make sure your arrows are way up at the top, not putting your arrows just at the end of your most recent point, all right? Your arrows are reaching all the way to the top right here. Nice work. I encourage you, pause the video, try out B, try out C, try out D. I'm not going to walk you through all of them, but you can unpause the video and see how you did. Good, where here you have all 4 parabolas all sketched. We've checked to see whether they open up or down. We've checked to find their vertexes, and we've checked to make sure that we're following the stepping pattern. I'm hoping at this point you feel a little bit more comfortable sketching your parabola from vertex form. Nice work.